नवाला आप थी ना लास्ट क्लास में, फर्स्ट क्लास ऑफ कोऑर्डिनेशन. ट्राई दिस क्वेश्चन. Nawal, you can send the answers just on the chat, okay? Nawal. Yeah, that is correct. Very good. So, Hanifa, please listen here. This is according to the Werner's theory. If I have a molecule like this, COCl3 dot 6NH3. Now, this molecule means that we have cobalt chloride and we are adding 6NH3. Okay, and from this we are getting a compound. Okay, now when this compound is being treated with AgNO3, I am getting how many moles of AgCl? I'm getting 3 moles of AgCl. Now, when I get 3 moles of AgCl, that means there are 3 independent Cl negative ions in the compound. The only way possible for that will be if I have cobalt with 6 NH3 molecules attached to it and Cl3 outside the coordination sphere. So this is the compound that we are getting when I'm mixing COCl3 and 6 NH3. Okay, right, next. Some important terms. Related to coordination compounds. Okay. Now, in coordination compounds, we have already seen what is coordination compounds. Coordination compounds are the compounds in which central metal atom is bound to a number of anions or neutral molecules by coordinate bonds. So what is coordination compound? First of all, write that. Right, next. The coordination sphere. The coordination sphere is also known as coordination entity. It is also known as complex ion. Okay. Please write the definition. It consists of central metal atom or ion bonded to a fixed number of oppositely charged ions or neutral molecules. Okay. For example, we have seen just now a compound cobalt NH3 whole 6 and Cl3. Now this whole complete thing, it is coordination compound. Okay, this complete thing is what? It is coordination compound. Now, in this coordination compound, we have something which is known as the central metal atom. And this is the central metal atom. Now, this complete thing inside the square brackets, this is known as the coordination sphere. Okay. And then we have something which is known as ligand. So here NH3 is what? It is the ligand. Okay. And the last thing that is remaining, the Cl3, it is just the counter ion. Write a question. Identify central metal atom, comma, number of ligands, and counter ion in following. Hanifa and Nawal, are you done till here? ये लिख दिया आप लोगों ने?
Yes, sir.
Okay. All of you understood this, no? Yes or no? It is just identification. Try some
Yes,
questions, you will understand more. Yeah. Right, number 1. Okay, what is the central metal atom and the number of ligands, and what is the counter ion? Send these answers on WhatsApp, okay? Do you want me to do one of these? Hanifa and Nawal, tell me. Should I show? Yes, Hanifa, can you please tell me?
The first one.
First one?
Yes.
First one? Okay. Hanifa, inside these square brackets are what? Coordination sphere, right? And inside this
Yes.
coordination sphere, you will always see only one metal. What is the metal that you can see in the coordination sphere? Tell me, Hanifa.
COCl2.
No, COCl2 is not a metal, right? It is a compound. What is the metal? Look at these things as elements. What are the elements that you can see here? You can see cobalt, you can see chlorine, you can see NH3, right? Elements and molecules in that sense. So what is the metal? Cobalt. Very good. Whatever remains after the identification of central metal atom or ion, it is the ligand. So Cl2 is also a ligand and NH3 is also a ligand. How many Cl2 we have? We have 2 chlorine and we have 4 NH3. Okay. And what is the counter ion? We have only one Cl negative. Got it? Yes or no? Please tell me.
Yes.
Okay. Okay. Okay, Hanifa, I've got your answer. Just a second, let me check it. First one is fine, second is fine, third one, yeah, very good. Third one is also fine. And Nawal, your answer. Very good, correct. So in the second one, the central metal atom is Ag. Number of ligand is 2, and what are those two ligands? Those are 2CN. Okay, cyanide. And what is the counter ion? Counter ion is going to be K plus. Now then we have central metal atom as nickel here, and the number of ligand is equal to 6 NH3 molecules. Okay, 6 NH3 molecules, and we don't have any counter ion here, and we don't have any counter ion here. Now, right next, ligands and types of ligand. Right next, ligands and types of ligand. So what are ligands? Please write. The atom or molecule or ion. The atom or molecule or ion which is capable of donating, which is capable of donating a pair of electrons to the central metal atom and forms a coordinate bond with it is called ligand. Right, note. As you can see, we have a metal atom and we have a ligand. Ligand is donating a pair of electrons to the metal atom. So if anything is accepting electron, that means the CMA, central metal atom or ion, is what? It is a Lewis acid, and ligand is Lewis base. And right next, types of ligand. On the basis of number of donor atoms, on the basis of number of donor atoms, the ligands are classified as the ligand are classified as number one, monodentate. Number two, also one more thing. Also monodentate are also referred as unidentate. Right next, bidentate or didentate. Then we have polydentate. Now, write the topic: monodentate or didentate ligands. Monodentate or didentate ligands. What are the monodentate ligands? They form coordinate bond with only one donor atom, and the central metal atom. Okay, so the donor atom will be how much? In unidentate, it will be only one. See, for example, we have H2O molecule. In H2O molecule, we have hydrogen, oxygen, and another hydrogen. Now, in this, we have oxygen atom, and only this oxygen atom is able to donate a pair of electrons to the ligand. Similarly, in the case of ions, you can also see Cl negative. Now, Cl negative will have, okay, it has 4 lone pair, but only one atom. That means the chlorine atom, or here the chloride ion, is able to form coordinate bond with the central metal atom. So no matter how many lone pairs you are having, but only one atom is going to form coordinate bond with the central metal atom. Okay, so there are a few monodentate ligands. Please note this down. Please note this down. Raise your hand once you're done. One more thing that I want to say is, let's suppose for the example, cyanide ion. Structure of cyanide ion is C triple bond N, with C having a lone pair and nitrogen also having a lone pair electron. Now here both of these can donate. Okay, this can also donate and this can also donate, but only one of them donates. Okay, but only one of them donates electron to central metal atom. ऐसा मत समझिएगा, here we have two donor atoms, but only one of them is going to donate. That means one donor atom is present, okay, when it's forming a bond. Capability दोनों के पास है. Carbon can also donate, nitrogen can also. But if nitrogen is donating, carbon cannot, and when carbon is donating, nitrogen cannot. So in a sense, you can say that rather we have two donor atoms, okay, two possible donor atoms, but only one of them is going to donate. That is why it is a unidentate ligand and not a bidentate ligand. Okay. Similarly, here is the case for thiocyanate. Sulfur and nitrogen both can donate, but only one of them is going to donate. Okay, don't get confused in cyanide and thiocyanate. In these cases also, only one atom is going to donate the electron pair to the central metal atom. Okay, is this clear, Hanifa, Nawal? Yes or no?
Yes, sir.
Okay. Please raise your hand once you're done. Hanifa, raise your hand once you're done. Okay, Nawal is done. Okay, great. Now write the next topic: bidentate or didentate ligand. Right, ligands having two donor atoms and can coordinate from and can coordinate to central metal atom from two different positions. Okay, so for example, we have an oxalate ion. The structure of oxalate ion is C double bond O negative, and here we have double bond O and another O negative. Now, this O negative and this O negative both can coordinate to what? Both can coordinate to the metal atom. And as you can see, it is donating, it is rather we have only one atom which is donating the electron, that is the oxygen atom. But we have two different positions. We have this position from which it is donating electron and this position from which it is donating electron. So we have in total two donor atoms and two different positions from which it is donating each other. And it is also written as C2O4, 2 negative, that is oxalate. Okay, so write the list of bidentate ligands also. This is glycinate, okay? This is glycinate. Write this down. Raise your hand once you're done. Hanifa, just waiting for you.